Thank you everyone for attending on this last day. So as Dave mentioned, I'll be talking about the Rocky Mountain population of trumpeter swans, specifically the Greater Yellowstone ecosystem segment of the population. And I know we've heard several talks this week about this segment of the population, but my goal of this presentation is to present a more broad overview of the movements and habitat use of all of the birds captured in the GYE over the last several years. And I have several co-authors all of whom were involved with the capture of these swans. So this is a map of the range of the Rocky Mountain population with a large polygon in Canada and smaller areas in Oregon in the GYE and even smaller areas throughout the Rocky Mountains. Trumpeter swans in the GYE have had a somewhat slower recovery than those birds breeding in Canada, and this has led to conservation concern for this segment of the population. Thus, there is a need to better understand the movements and habitat use of swans in the GYE. So what do we already know about movements and habitat use of trumpeter swans? There has been past concern about GYE swans not migrating during the winter. This is because Canadian breeders also winter in the GYE, and this can lead to high densities of birds concentrated in this one localized area. So it may be important for some of these GYE swans to migrate elsewhere for winter. Past studies have shown that survival may also be higher for swans that migrate than for those that do not migrate. And so this also indicates the importance of migration for these birds. For habitat use, swans may avoid higher elevation areas, and they may also use agricultural areas as we've seen this week, especially during the winter time. So with this background in mind, we developed two objectives for today's presentation. The first is to examine seasonal movements of trumpeter swans captured in the GYE. And I also have a few birds that were captured in Oregon. And so I'll be including those in the data and the maps that I'm showing today. The second objective is to identify environmental characteristics of trumpeter swan locations. And for this talk, I'm including land cover and topography. And I do want to point out that these are very preliminary results of everything that I'm presenting today. We still have a lot more work to do for this study, and I'll be talking about next steps at the end of my talk. So swans were captured between 2019 and 2021 throughout the GYE in Oregon, and 84% of these captures were in the summer, specifically in July. And of course, this is the time of year when these birds are molting. And Cody gave a talk earlier this week discussing how they were captured, so I won't repeat that. But again, we place the all too familiar by now Ornatella collars on these birds. And the frequency of the data collected by these collars varied, but most of the data that I have in my data set was between every 15 minutes to every couple of hours. There were 5 projects involved in this study. We have Fish and Wildlife Service, Camas National Wildlife Refuge, a small group of birds in Montana, Summer Lake, Oregon, Teton Basin in Idaho, and Wyoming Wetlands Society in Wyoming and Montana. And so Andrea talked earlier this week about some of the Camas birds. Brandon discussed some of the Summer Lake birds, and Cody talked about the Wyoming Wetlands Society birds. But again, they gave more specific details about their birds, and I'll be giving a more broad overview of movements and habitat use of all of the birds captured in the GYE in Oregon. So for the movement analyses, I first assigned each telemetry location to one of 4 seasons, and I got these dates from the published literature. So pre-breeding was March 1st to April 30th. Breeding is May 1st to September 30th. Post-breeding October 1st to November 30th. And winter December 1st to February 28th. I then determined which birds migrated to Canada for breeding. And for those that did not go to Canada, I calculated the distance moved for each bird in each year between the breeding area and the eventual wintering area. Based on those distances, I defined what I'm calling a U.S. migrant as a non-Canada swan that moved at least 100 kilometers between the breeding and wintering area. For the habitat analyses, I mentioned I looked at topography and land cover. For topography, I associated each telemetry location with two different variables, elevation and a topographic roughness index, or TRI. And so TRI is a measure of landscape roughness or terrain ruggedness. And the lowest value it can be is 0, which represents a completely smooth landscape. I also associated each telemetry location with a land cover, one of these 9 land cover types. And I used a North American data set because I had data from both US and Canada. So we'll get into some results. We had a total of 62 swans that were captured throughout the GYE in Oregon. And again, these beige polygons are the range of the Rocky Mountain population. And the different colored circles are capture locations for each of these 5 projects that I mentioned earlier. Of these 62 swans, we had data for 56 of them. And this represents 107 bird years. So many of these birds had data for more than 1 year. These data were collected between March of 2019 and July of 2022. And I just used July as the cutoff for this presentation. Several of these callers are still transmitting data. And so this map shows all of the data for these 56 swans. And this is over 348,000 locations. So first we'll show you the data for the birds that moved to Canada. So we had 10 swans in our data set that migrated to Canada in at least 1 year. So that's 18% of our data set. 6 of these birds were captured in the GYE in summer in the breeding season, and then in subsequent years migrated to Canada for breeding. We also had a 7th bird that was captured in the post-breeding season, but spent the following breeding season in the GYE, and then the next year went to Canada. So 70% of these 10 swans spent at least some time in the breeding season in the GYE, and then migrated to Canada for breeding in later years. This represents 16 bird years, so several of these swans migrated to Canada in more than 1 year. So in these next couple of slides, I'll talk about 2 of these Canadian breeding swans. This one, Swan 201376, I thought was very interesting because this looks like it's just one track to me, but this is actually 3 different tracks, 2 north, 1 south. So this bird used an almost identical migration route for all 3 tracks. This bird was captured just west of Jackson during the pre-breeding season of 2021, moved up to Canada that same season, stayed in Canada through breeding season, then came back down, and post-breeding season of 2021, wintered near Rexburg and Idaho Falls, and then went back up to Canada in pre-breeding season of 2022. So pretty much the same route, all 3 trips. In contrast, this bird used a different migration route. This is Swan 201391. It was captured at Camas National Wildlife Refuge in the breeding season of 2020. The following pre-breeding season of 21 went up to Canada and took this more westward route, spent that breeding season in Canada, and then came back down in the post-breeding season using this more eastward route. Wintered in the Jim Valley Soda Point Reservoir area in Idaho, and then went back up to Canada in pre-breeding season of 22 using this more eastward route. So this bird used a different route to migrate between the 2 years. So moving on from the Canada breeders, we then had those birds that stayed in the GYE. And so this was 48 swans representing 58 bird years. And for each of these birds, I calculated the distance between the breeding area and the wintering area. So this histogram shows those distances, and 55% of them were less than 100 kilometers. 71% of them were in the south direction, and 16% were either east or west. So what I noticed is that when they traveled less than 100 kilometers between breeding and wintering areas, they tended to go back and forth a lot. They didn't really stay put in the wintering area. So that's why, and then when they were traveling more than 100 kilometers, they did tend to stay put more on a general basis. There were some exceptions, of course, but mostly they stayed put when they traveled more than 100 kilometers to their wintering area. So for that reason, I used 100 kilometers as a cutoff for what I'm calling a US migrant. And so this slide shows the data for those birds. This is 23 swans representing 25 bird years. And again, these are birds that travel between the breeding area and the wintering area over 100 kilometers. Those same 7 swans that I mentioned earlier that were in the Canada group, every one of them had a long distance movement between the breeding and the wintering area. And then the very next year migrated to Canada for breeding. So these swans were in the GYE in the breeding season, had a long distance movement to a wintering area, and then the next year migrated to Canada. So again, I'll show a couple of these swans that had these long distance movements. And I chose to show you the 2 swans that had the longest movements. So this one is Swan 211567. This one was captured at Red Rock Lakes in the breeding season of 2021, and then migrated west to the Owyhee Canyon in eastern Oregon during the post-breeding season, and stayed there until the data ended in January of this year. So we don't know the fate of this bird. And this was a 485-kilometer movement west to Oregon. This one was captured in Doney Lake, Montana in breeding season of 2020. In the post-breeding season, moved south to Ennis Lake, and then in the winter season, made another movement south to the Henry's Fork of the Snake River area. This was a 330-kilometer movement south. So I'll move on to the habitat use section. Again, we looked at topography and land cover. So this is topography. And the 2 variables I looked at were elevation and TRI, that topographic roughness index. So these are mean values of where the telemetry locations were. These are the mean values of elevation and TRI across all swans for each of the 4 seasons. I did not look at individual variation. That's something I need to do in the next steps. So these are just mean values across all swans. Some individuals, of course, will not follow this pattern. So during the pre-breeding, post-breeding, and winter seasons, mean elevations used by swans were about 1,500 meters, but in the breeding season, it was lower at 1,300 meters. So mean elevation was lower in the breeding season than it was in the other seasons. For TRI, I mentioned that a value of 0 represents a completely smooth landscape, and these values are all very close to 0. So TRI was low across all seasons, but it was somewhat higher in the winter time. So they are using slightly rougher landscapes in the winter. For land cover, I'm showing 4 tables, 1 for each season. And each of these shows the top 3 land cover types used by swans. And so, of course, for the pre-breeding, post-breeding, and winter seasons, the top land cover type was water wetland. The second most used was crops. And then the third was either shrubland or grassland. In the breeding season, cropland was rarely used. And in fact, it was only used about 3% of the time compared to 9% to 18% in the other 3 seasons. So cropland was used in all seasons except during breeding. So some preliminary conclusions for the study. Some of the swans captured in the GYE in summer do migrate to Canada in subsequent years. 40% of the swans in our data set migrated in winter, but they still usually stay within that tri-state area. We did have that 1 swan that went to Oregon, but all of the others stayed within the GYE. Swans typically use low elevation and smooth landscapes. They will use lower elevations when breeding and slightly rougher landscapes in winter. And then finally, swans forage in agriculture in all seasons except during breeding. So the next steps for this project, we plan to continue to collect telemetry data through 2022. And then I would like to do, I haven't done any sophisticated analyses yet, so I'd like to calculate daily distances moved and associate these same landscape variables with daily tracks rather than just simply the telemetry locations. I'd also like to look at some weather variables such as wind and precipitation. And like I said, I need to do some statistical analyses, and then we expect that these results can inform the conservation of trumpeter swans in the GYE. So thank you for your time, and I can take any questions.